Algebra class. I am going to do a little video on some things we've been talking about in class. So I want to focus first off, and I'm playing some tools here, so see if I can do it really well. I want to focus in on this box here for a second. We talked about, generically speaking, change of outputs is basically dependent on your change of inputs times the constant rate of change, also known as croc. If you look close enough, it's the same formula as what you did in high school called point slope form, y minus y1, blah, blah, blah. But we just want to make sure, because some people forget that formula, and if you remember, the change of output is always going to be the multiplier times the change of inputs, then you can have some work with it. And then I've also rewritten it a couple different ways so you can see it works with multiple ways. So with that said, let's go ahead and focus our attention on number 6 now, where it says find the constant rate of change and the reference point. And by the way, up there in the notes, the reference point would be x1, y1. All right, why don't you pause the video and see if you can figure it out. All right, welcome back. I am going to do my best to figure this thing out, the device first off. So this is going to be interesting. The constant rate of change is the number that's being, remember, multiplied by the change of the inputs. And so these are my input variables. And so 11 is the change of the rate of change. So we're going to call that croc equals, I guess I could have just used the computer keyboard, equals 11. Okay. And then the reference point would be this number here, 5. It's always pretty much the opposite what you think. So the reference point, we always put the x-coordinate or the input variable first, the reference input, and then 22, of course, would be the output. Because if you put 11, or if you put 5 in here, you get 5 minus 5 is 0. 0 times 11 is 0. 0 plus 22 is 22. So the output, remember, depends on what you put in. That helps in case you get a weird problem. All right, am I allowed to change colors on this? Oh, good. Let's try different thickness. Okay, so again, check your answer, pause the video at any point. This particular croc is going to be, and that pencil is way too thin for me for next time, so I will not do it that thin, equals negative 0.4. Okay, and now the reference point, well, what number can I plug in here to make it 0? Well, negative 6. So negative 6 goes in, and then that would make that whole thing be 0, and then you get negative 10.6. So hopefully it's getting a little easier for you. The variables don't really matter, it's just where the parentheses are, basically. All right, let's try another one. I'm going to try a different color just to play with these a little bit. So croc, constant rate of change is that 3750? No, he's not next to the parentheses, so 100. So whatever the difference of the x's are times 100, that's the croc. And then what number can I plug in for this x to make that part whole equal 0? 12, you got it. And then of course 3750 would be the output. Now notice they put the output first, because sometimes that makes more sense. You start off with 37.5, let's say, $1 million, and you're adding 100 per unit. All right, this one is a little different. It's actually what we used to have it on the left side, but if you were to add it to the other side, add +2, then it would be where it belongs, right? We'd like our variables on the left side to be solo. All right, so croc, and that's why most high school teachers or most college teachers don't like the way the high school teachers do it, because we don't like it y minus, we like it y equals. So the croc is 0.5, and then of course your reference point would be 5, 2. Okay, so hopefully that works a little bit with you guys. All right, so let's see if I can scroll. I don't think, oh, I have to exit drawing. So go ahead and take a picture of this, or just rewind the tape. I'm going to exit drawing, and I get to scroll. All right, with that said, now we get to just find the slope or find the constant rate of change. Go ahead and do these problems if you have a piece of scratch paper or something. All right, welcome back. What color do we like, guys? I don't know. I think purple was okay. Let's try the magenta. All right, I'm just going to use this formula from the old days, y2 minus y1. So the change of the outputs, I'm going to choose this direction this time because 34 is bigger, and I like my negatives to be not there. So 34 minus 11 equal or over, and if you do that, you have to do this, 12 minus 0, which is just 12. And did I make up a stupid problem? Probably. Looks like it's 23 twelfths. All right, and that can't be reduced. All right, I know what's gonna happen in a few minutes, so I'm gonna write that down. 23 twelfths. So that's my that's my slope. And ooh, I like blue. Okay, here we go for this one. I'm going to go 0.4 minus 0. Man, this lag is terrible. And then negative 9.5 minus, and this is what you do on your test too. You just show me the work, then you use the technology to figure out the answer. And that's what we do right now. So, negative 9.5 subtract 12.9 is negative 22.4. So I'm going to cross that out, put negative 22.4. Okay, I'm going to try using the other pen because the lag is making me go crazy. So 0.4 divided by negative 22.4 gives me a weird decimal, but I'm going to do on my calculator, on the TIs, you can do math, enter, enter, and it gives you a nice clean fraction. I believe on Desmos too, you can do this, but it's negative 1 over 5/6. That's going to be not fun on the next section we do this. All right, this one I'm going to go this way now because 11 is positive, so 11 minus a negative, and a minus a negative means positive, so 3.5 over 7 minus 3.5. I'm hoping this will be nice and friendly. This pen is not, I need to buy a stylus, so I think they're only at 20 bucks or something. 14.5 over 3.5. Let's hope that's a clean number. 145, 350. It wasn't actually. 29 sevenths. It's not terrible, but 29 and 7 are both ugly prime numbers. All right. You guys okay with that? That's just finding the slope. I'm going to go ahead and erase it now. So the next part just has the same problems. Find the linear function for the following coordinates. I got to keep track of time. So it turns out on the first one we don't have to do anything extra because my function, and I'm going to use this this tool now here, which I believe is here. Okay. I don't think it's much as the lag. This is right here is my y-intercept. So I can actually use the slope, which I found was 23 twelfths, and write y equals 23 twelfths, 23 over 12, x, that's my independent variable, plus that 11. So when I put 0 in this function, it has to equal 11. So that makes that so much easier to work with. These other two guys, we're going to have to figure those values out. And you have a couple options. I'll do option 1 for B. So you're given a slope, and I remember one of the slopes was negative 1 over 56. I think that was the other one. Oh, it's 29 sevenths was the last one. Negative 1 over 56 was the first one. And if I got this backwards, just forgive me because I erased everything. I should have not done that. So the first option is to use the point slope form. So pick one of these 2 points to work with. I'm going to work with this one here because it includes a 0. So y minus 0, see what I was doing there? Negative 156. See, that's why I don't like this, because it has this ugly problem. Oh, I'm going to get away with some extra work here for a second. X minus 12.9. All right, so the 0 goes away, and it just says linear function. It doesn't say what form to put it in. So I'm just going to keep it like this, and you can too, as long as I don't specify point slope or slope intercept form or whatever. So you can keep it like this. And this makes more sense to us because now we have a reference point, which is 12.9 comma 0. The slope is that, and so forth and so on. All right, let me see if I can change my color on this page. Okay, good. On C, the slope was 29.7. So that's option 1. Option 2 is not as friendly, but it works sometimes when the numbers aren't like crazy. So I just pick an x and a y. I'm going to pick this one here, x and y. And I'm going to use y equals mx plus b as my format. So y equals m, which was 29/7 times x. Ooh, that works nicely because 7 and 7 are going to cancel. Plus the y-intercept. The 7's cancel out. I'm going to subtract 29 from both sides. And you get negative 18. So my y-intercept is negative 18. So my equation would be y equals 29/7 x minus 18. And of course you can graph this and then check to see if 7 and 11 are on that graph, and 3.5, negative 3.5. So those are two options. You can do both of them when they're appropriate, or just pick one lane and stay in there. So, okay, the next part, if I haven't already made your brain melt, is, I don't think I could exit drawing. Yes, I can. Okay. Well, that's not part of the drawing, though. Is to determine the average rate of change between values. So between 0 and 1, between 3 and 10, between negative 2 and 4, and so forth. So instead of, I wish I could have technology on this screen at the same time. I probably could, though. I'll have to play with that next time. So this is a parabola, and if you don't know what that is, that's fine. This is just a function, and we're going to put, I'll do this. I think this is how I normally do my stuff. It's actually f of t, but I'll fix that. Okay, so we're going to put 0 in for the function, and we're also going to put 1 in. These are the endpoints. So it starts at 0 and it ends at 1 on this interval. So if you put 0 in for the function, you get negative 17.2. Okay? If you put 1 in there, that's where I got to get a calculator out. 4.53 times 1 squared, which obviously is 1, minus 17.2, so negative 12.67. You try to be as accurate as possible when you're doing these calculations. And then you're going to do the subtraction, so negative 12.67 subtract negative, which means it means positive, 17.2 all over 1 minus 0, which is perfect because all I have to do is math is on what math I have to do is on top. So I get nervous on this computer here thing. Plus 17.2, so 4.53. So the slope, or the rate of change, or the average rate of change, is 4.53 between 0 and 1. Okay? Now remember, I think this graph looks something like, it's down here at negative 17.2, and it goes upwards, and it goes upwards. So what that's saying is, from 0 right here to, let's say, 1, because we already know it's negative 12.67, between those two spots, let's see if I can get my graph to show up. if I drew a line between those two dots right there, the slope of that line is 4.53. So if you see a graph problem, very similar, just put the x and y coordinates in a table and go to town. Okay, now I've done this one. You go ahead and pause the video and see if you can figure out the next one while I clean up my mess here. Let's see. I think I can draw on this. That's fine. All right. So t, f of t. Here's my little table. And we're going to put 3 in for the input. Find the answer for f of t. Put 10 in. So in this case, we're going to go up here someplace and way up here. And we're going to see what that slope of that line is. Okay. I'm going to do a copy and paste thing with my TI. I just copied and pasted the function, changed 1 to 3, got 2357. And then I'm going to do it again. This time change 3 to 10. 400, so it's way up there. 435.8. So to find the slope, you take these two numbers, you find the change in the y's. So 435 subtract 2357, and I get 412.23. Now that's just the top. Then we subtract the inputs, which would be 7. And we'll divide that by 7, and I get 58.89. Okay, because of my time, I'm not going to do the next two, but that's what we do when we do functions that are not linear or graphs that are not linear. We can also do it for the linear ones too, but all right, this next batch is talking about Desmos and how we can do regression. So what I'm going to do is I'm going to take a picture of this because it's not going to be on my screen when I do the next part. If you know how to do this already, go ahead and you can skip this part of the video or fast forward and see if you got the right answer. Okay, now for the people who have calculators, Desmos, you never know what you're going to get with that. Oh, that poor guy died. The actor for Dawson's Creek. I never watched the show, but I've seen it in other shows. All right. I think I can move this while we're doing this. Yes, okay. So all we need to do is for Desmos, and this is your phone or the computer at home, you've clicked the plus part, which is on the left side. I think I wrote that in the directions too. You're going to go to table, and then you can change your variables to cleaner letters, but I'm just going to keep them x1, y1. And you start typing in the left side. If it's going up by the same amount, it self-populates. So it looks like ours are going up by 10. So I'll just use that feature. These are the ones I have to do 10 key now, 2249. If you don't know 10 key, it saves you a lot of time if you have a keyboard that does that. ID 249, 10,621. Don't put the commas in here, guys. Some people keep trying to do that. Desmos does not like commas, or at least not the way we think they are. Okay, and somewhere on the graph is way up there, the data points. You can scroll out and try to find them, but it's going to take me forever because I'm only 150 and these are 6,000. So to explain what's going on here, if you made $20,000 last year in 2025, you will be taxed 220. You're responsible for 2249. Now your employer should have taken some money out, right? And if they took out less than that, then you have to pay extra. Or if they took out more than that, then you get a rebate or a refund. So that's why at tax season, then we have to fill our taxes out. So we don't want to graph this and try to figure out the slopes and everything. So we're going to do a regression. So up here in the left corner, it says add regression. And it's a little line with 2 dots on both sides of it. Click it, and then it gives you some choices here. The first one is defaulted to linear regression. You have other choices if you click it. We're going to talk about linear this year, semester quadratic, probably exponential, and maybe power logarithmic. But right now this is just linear because we're looking for a straight line. And I want you to notice some couple things as you write down the answer. And I write the answer too. We have y equals 188 point and a big number, so we'll just go 0.2 x minus 2149.5. So there is my model for this data, and I wish I could show you the picture. And notice the other thing is called r squared. This number here is called a correlation coefficient. And all that means is it tells you how strong the data is to the model. And that means it's 0.98. 1.0 is perfect. So I always thought it was a percentage. My teacher told me it wasn't, but it works every time for me, so I feel like it's 98% good, right? All right, I don't know. I think I probably should stop the video now, and then I'll come back if I need to answer the questions. Okay, bye.